So thank you all for coming. We're delighted to host you here at the Black Hole Initiative. Our office space is just next door in the building next to the Sheraton Commander. It's number 20 Garden Street, as you can see here in this picture. And that's the way the building looks at the bottom right corner. And we will have a visit to that office space. This is, in my opinion, one of the most beautiful buildings at Harvard. We will go there at 12:30. The Black Hole Initiative is the only center worldwide focused on the study of black holes. It is unique in its interdisciplinary scope, extending from the humanities, in particular philosophy, to the sciences, astronomy, physics, and mathematics. As director of the Black Hole Initiative, I find it particularly exciting to listen to all the wide-ranging discussions that we have among these different disciplines. Last year, we inaugurated the Black Hole Initiative, and Stephen Hawking requested special permission from his doctor to attend the inauguration. Robert, and you can see here a photo taken at Sanders Theater, not far from here, with the principal investigators on this initiative that I will describe in a minute. Now, Robert Dijkstraaf, the director of the Institute for Advanced Study that you can see in this photo at Princeton, Einstein's final academic home, he worked for 4 full days on the mural that you see next to him, which is currently hanged on the wall of the Black Hole Initiative next door. And we are really grateful for his artistic vision. You can see in this photo a black hole binary here, Einstein's equations, the information paradox, strings, that's the way he sees, that's a subject very dear to his heart, and an accretion disk as well. We are in particular grateful for the Templeton Foundation for supporting the Black Hole Initiative for the first 3 years. We received a grant of $7.2 million for the first 3 years. We are now completing the first academic year, and we are celebrating it with this conference. You can see here a group photo of some of our postdocs and students and senior members, and we will be getting 6 new postdocs soon after the summer. Overall, we are gathered here to celebrate the successful operation of the first academic year of the Black Hole Initiative. This was an exciting year, and we very much hope that we will continue beyond the 3 years of funding that we currently have. There are currently 2 postdoctoral fellows, but they will be joined by 6 more in different disciplines, going from philosophy to astrophysics, to the Event Horizon Telescope, to physics, gravitational wave astrophysics, and mathematics. So we span a wide range of topics. My original concern was that the multiple languages that people speak in the different disciplines will lead to a situation similar to the Tower of Babel, where people spoke different languages and could not cooperate. It led to my delight to actually an opposite outcome, where we have a lot of collaboration that are being fostered at the Black Hole Initiative. We will hear more about that later on. Personally, I was at a young age very interested in philosophy, and this closes a circle for me. So I'm very delighted to see people from the humanities together with the sciences. And we are now here to start the first annual conference on black holes. But before we do that, let me introduce the principal investigators of the Black Hole Initiative that you will see around. They are not speaking at the conference, and that's why I wanted to introduce them. The only one that is speaking is actually Shep, simply because he leads an observational project, and he is the main spokesperson for that Event Horizon Telescope, which is aimed at imaging the shadow of the black hole, the silhouette of the black hole at the center of the Milky Way galaxy, and also at M87, and potentially in other galaxies later on. And currently there are 6 sites that are coordinated around the globe with 8 different telescopes from where data was collected. As of a few weeks ago, the weather was fantastic. The data will be analyzed in the coming months. And we very much hope to get an image similar to those that are shown here from theoretical calculations, where you see the radiation around the black hole appearing as a crescent of a moon. And the shadow is what gives us all the information about whether Einstein's theory of general relativity is correct or not. And so this is the observational aspect of the Black Hole Initiative. Another senior member is Peter Galison, who works on the history of science and philosophy. And Peter also makes films. He wrote a number of important books. And he is actually filming a film on on black holes in general. And you will see a short segment from that film, a trailer, this evening at the banquet. Ramesh Narayan works on theoretical astrophysics and made the pioneering discoveries or found important results in the context of accretion of gas onto black holes. And Ramesh is planning to have actually a sabbatical at the Black Hole Initiative next year, and he's very much involved in many aspects of our activities. Andy Strominger works on the physics of black holes, both involving quantum mechanics and general relativity per se. As he gets older, he tends to work on subjects such as soft hair, and where he collaborated with Stephen Hawking and Malcolm Perry on a couple of papers recently. S.T. Yao, Xingtang Yao, is a highly distinguished mathematician, member of the Black Hole Initiative, interested in the stability of space-time and black holes more generally, defining energy in the mathematical sense rigorously within general relativity. And finally, myself, I work in theoretical astrophysics, as many of you know. So that concludes the introduction. Of course, an interesting question is whether we can visit a black hole anytime soon, or how to make a black hole. I just wanted to give you a brief recipe for how one can make a black hole if we wanted to in our backyard. It's basically, it requires, if we wanted to have a supermassive black hole, it requires filling the orbit of Jupiter with water. That's all. If you ask how much mass will be associated with that, it will be roughly 1 billion solar masses. The only problem is we don't have that much water in the Milky Way galaxy, but that's all you need to know. You need to put so much mass within that kind of a space in order to make a black hole. Surprisingly, the universe made such objects very early on.